In this tutorial, we're going to use Excel to conduct some regression analyses in order to examine the relationship between estimated biomass weights and actual biomass weights that were collected using a double sampling method. As you may recall, double sampling is an approach that we use when we're interested in being able to estimate a variable that is either difficult or time-consuming or costly to measure. However, that variable excuse me, can be estimated, and it's much easier to estimate than it is to actually measure. So with double sampling, we estimate frequently and measure infrequently. We then use regression analysis in order to examine the relationship between the estimated values and the actual values. Once we can describe that relationship and develop a regression equation, we use that regression equation to adjust the estimated values to reflect the actual the actual biomass of the data. In this first example we're going to look at is data that was collected by a person who I am calling persistently pessimistic. Someone who says that the cup is half empty. And you can see the reason for this is here we have for 15 quadrats, we have 15 estimated weights, and we actually measured 5 of those weights. This person is very persistent in their measurements and consistent in the relationship, but they're always underestimating by exactly half. So that's why I say cup half empty. The estimated value in quadrat 3 was 9 grams per quadrat, and the actual value was 18. In quadrat 6, the estimated value was 20 quadrats, and the actual weighed value was 40 grams. And so you can see that if you examine all of these where we both estimated and weighed, that this relationship is consistent throughout. So in order to do a regression analysis, the first thing we have to do is graph the data in a scatter graph. So I'm going to highlight the data and then go up to the menu at the top for insert and select a scatter graph. Now I just want a simple scatter graph of the points, and that is quickly displayed on the worksheet. You can see that it is a perfect relationship. It's a straight line, but we don't have the regression equation or the coefficient of determination displayed, and we want that. So if we make sure that we're still highlighted on the graph, the chart tools are displayed up above, and if you go to layout, you will see an option for trend line. So we don't want to go with a default trend line. We want to actually make sure that we're specific in the options that we select. So we're going to go to more trend line options. And I'm going to tell it to display the regression equation on the chart, and also to display the R-squared value on the chart. I'm not going to set the intercept at 0, so I don't recommend that you do that. Okay, and so now we have the regression equation and the R-squared value, or the coefficient of determination, displayed on the chart. And you can see that, first of all, the regression equation describes the relationship between the independent variable, which is the estimate in this case, and the actual or clipped value. And the R-squared value tells us about the strength of the relationship, or how much of the variation in the actual value, y, is explained by the variation in the estimated value, x. Okay, so what we really want, R-squared value of 1 is perfect. You couldn't ask for better than that. Obviously these data are slightly made up. And what we're going to do is we want to now take these estimated values and then convert them to adjusted estimates. And so what we'll do is we can copy this equation into the cell in Excel. I'm going to have to make a few adjustments because in an Excel equation we don't want the y in there. We actually don't want the x in there either, and we have to always use an asterisk to indicate that we're going to multiply. So I'm going to replace x with the value that was estimated in quadrat 1. Okay, and as we can see, as we would have expected, the estimate was 35 grams, and now the adjusted estimate is 70 grams. Okay, having done that, we've got the equation set. All we have to do now is copy this equation, which we can do by right-clicking or using the copy function up here, and then just select down and then paste. And so we're going to paste that formula in here. And for every one of these values, of the estimated values from each one of the observations, we now have an adjusted estimate. And so the next thing to do then would be to come up with a mean value of the biomass in terms of grams per quadrat for this sample. Now, in general, if you recall, we used the data here as our training data set. And so it's really not a good idea to use your training data in your estimate for the area. So I'm going to select and remove the values that are associated with the samples that were both estimated and weighed. And that way, if I now go in here and down here, first I'm going to type in mean, because that's my mean value. And I always like to include my units, okay, so that I know what that is. And I'm just going to say equals, and I'm going to go back up here, and I'm going to tell it I want to do an average. And I have to make sure and tell Excel exactly which cells I want. Now, it's going to ignore or skip over the ones that are blank. So what we get is from this value, from these data, an estimate of, on average, 64.2 grams per quadrat. Now let's look at another example of some other data that were collected by someone else. This person is an eternal optimist and a cup half full kind of person, but not perfect. And so you'll see that in general, their estimates are about twice what the actual values are, but it's not perfect. So 56 isn't exactly twice what 30 is. So we're going to go through the same process here and go up to insert, get our scatter graph. We've got our graph now, and we need that regression equation. So we're going to go up to layout, ask for the trend line, and get the equation displayed and the R-squared value displayed. Now, as we can see, we don't have a perfect relationship. It's not a perfectly straight line. And so that's why the R-squared value is not 1. It's still very good at 0.97. That's a very good R-squared value. But basically what that means is that we don't have a perfect relationship in the ability of our independent variable x to describe or predict the variability in y. But we do have this formula, and so we want to use the regression formula again here. So I'm just going to copy this over. I could type it in on my own, but with all those digits, I tend to think that I'm going to possibly have trouble with that. And I have to go back and remember that Excel needs to have the asterisk if it's multiplying. It doesn't want the X in there, but what I do want now is to tag the cell that has the estimated value for quadrat 1 and make sure that my formula looks pretty good, and it does, so I'm going to accept that, hit the enter button or select, and basically what this has done is that formula has converted 35 grams per quadrat to an estimated, an adjusted estimate of 17.57. Now, what I'm going to do is I'm going to copy this formula and paste it down here, okay, and go through the same process of removing. Now, if I had a large number, I could always sort these data. In fact, I can show you how I would do that. So I'll put those, actually maybe I won't be able to do that. Put those numbers back, yeah. And so one thing I could do if I wanted to do this quickly, if I had a large number of a large amount of data, is to sort. And so I don't want to lose my quadrat numbers, so I'm going to take this entire field, including the quadrat numbers, the estimates, and the actual and the adjusted estimates. I'm going to go into data and sort. And I want to sort by what's in column C, which is the actual. I'm going to do that. And you see that way now, what I've done is it's very easy for me to highlight these cells and to clear the contents of those cells. And then because I already created my formula up here, I'm just going to copy this formula and paste it down here. And what we can see is, based on this set of data, that the mean value using the adjusted estimates for these 10 quadrats here is 16.2 grams per quadrat. So let's look at just one more example, and this is someone who has more realistic data. It's not always twice, and it's not always half, but it's more realistic. And so we're just going to go through this process one more time, but quickly. Go up to insert, the scatter graph. We want the scatter graph. I've got my chart. I'm going to go up to layout, request the trend line, and tell it that I want to display the regression equation and the R-squared value on the chart. And here they are. The R-square, you can see in this case that this person sometimes overestimates and sometimes underestimates. So if this is the estimated value down here on the X, we have an estimated value of, for this particular data point, of 50, the estimated value of 50, and an actual value of 41. In other cases, it's slightly above the line. Okay, so we're going to use this same equation here, copy it over, and clean it up to keep with the Excel syntax. Okay. And I'm going to get that cell in here, and then that should be sufficient. And again, we've got that equation. So I'm going to just copy down here for all of these values. I'm going to clean out the ones that I don't want to include from my training set into the actual set. And so the estimate of the mean values in grams per quadrat is going to be based on 10 quadrats instead of on 15. And so again, just to show how that's done, you do equals, go up here to the function, ask for average, and remember that you do need to tell it which cells. I want all of these cells. It's not going to pay attention to the ones that are empty. And in this case, I have a mean value of 31.1 grams per quadrat. So that's a quick explanation of how to use Excel to do regression analyses.